Hello, mathematicians. Today we're going to be talking about the L'Hopital's rule. So the L'Hopital's rule helps us to find limits where when we substitute, we don't really get something that makes sense. So let's look at this example. If we substitute x for 0 when we take this limit, we get sine of 0 over 0. Sine of 0 is just 0 over 0. What are we going to do now to find this limit? What does 0 over 0 mean? We can't really tell. This is called an indeterminate form. An indeterminate form is 0 over 0 or infinity over infinity. Because we don't know how to describe what's really happening. 0 over 0, is that approaching 1? We're dividing by 0. It's hard to say. Sometimes we can factor to cancel things out and we get another number. But sometimes, like in this case, sine x over x, we can't cancel anything out. That's where the L'Hopital's rule comes into play. So, L'Hopital's rule says if the limit as x approaches c of f of x is 0 and g of x is 0, then the limit as x approaches c of f of x over g of x is equal to the limit of f prime of x over g prime of x. Notice this is not the quotient rule. We're taking the derivative of each part separately. So we got 0 over 0 here. So let's write out our conditions to satisfy L'Hopital's rule. So the limit as x approaches 0, in this case c is 0, of the top part, sine of x, is 0. And the limit as x approaches 0 of the bottom function is x. We plug in here, we get 0. So then we can say L'Hopital's rule applies. So we can take the derivative of each part, and that will be equal to the limit. So limit as x approaches 0, we're going to take the derivative of sine of x, cosine x. Derivative of x is 1. Again, we're not using the quotient rule here. We're taking the derivative of each part of the fraction separately. So now let's try and plug in 0. Cosine of 0 is 1. And in the denominator, we just have 1. So we get our limit is equal to 1. Now, when we have here in the top 0 over 0, it's very important that you don't put equals, because an indeterminate form is not equal to this limit. Okay, so be careful, do not put equals here. That is not correct. So I'm going to erase that. Let's do another example. Here we have the limit as x approaches infinity. Now we've done this with infinity before, and we could say e to the x and x squared. Which one is bigger? E to the x is bigger, so we're going to have infinity, a bigger infinity on the top, so we'll be approaching infinity. Now let's say you forgot about that. You can also use L'Hopital's rule. So let's take the limit as x approaches infinity of our top, that's infinity. The limit as x approaches infinity of our denominator, that's also infinity. So we can say L'Hopital's rule applies. So let's take the derivatives. Limit as x approaches infinity of e to the x just stays the same. And the derivative of x squared is 2x. Now if we plug in here, we're going to get, again, infinity over infinity. Again, we can apply L'Hopital's rule. So we can say the limit as x approaches infinity of e to the x is infinity. and the limit as x approaches infinity of 2x equals infinity. L'Hopital's rule applies. So let's take the derivative again. You can take the derivative as long as you keep getting some indeterminate form. Derivative of e to the x, e to the x. Derivative of 2x is 2. So now when we plug in, we get infinity over 2, which is infinity. Now because we have infinity here, we can't put equals. So I'm going to change that to an arrow. So the limit as x approaches infinity of e to the x over x squared is infinity. Let's do another example. So remember, always try and plug in first. So if we plug in here, 0, sine of 0 is 0, over 0 plus cosine of 0 is 1. So we get 0 over 1. So what is that? That's not an indeterminate form. That's just 0. L'Hopital's rule does not apply here. And in fact, if you did apply L'Hopital's rule, you would get the wrong answer. So make sure you're always substituting first. Let's try one more example here. Limit as x approaches 0 from the right of x times ln of x. So if we plug in 0 here, we get 0 times ln of 0. Well, the graph at 0 of ln of x goes down here towards negative infinity. So we have 0 times negative infinity. We don't know what to do with that. So we want to try and get it into a form where we can use L'Hopital's rule. We can't do that now because we don't have a fraction. Let's see if we can make this into a fraction. Well, we can write x is equal to 1 over 1 over x. Remember, when we divide, we can multiply by a reciprocal. So that's 1 times x over 1 equals x. So now we can write this as limit as x approaches 0 from the right of ln of x over 1 over x. Dividing by the reciprocal is the same thing as multiplying. So now if we plug in 0, we get negative infinity. 1 over 0 would be, from the right, positive infinity. So now we can use L'Hopital's rule. Limit as x approaches 0 from the right of ln of x equals negative infinity. The limit as x approaches 0 from the right of 1 over x is positive infinity, so L'Hopital's rule applies. So let's take our derivatives. We can rewrite this as x to the negative 1. So limit as x approaches 0 from the right, derivative of ln of x is 1 over x, over the derivative of 1 over x, or x to the negative 1. Bring down that negative 1, x subtract 1, negative 2. So now let's rewrite this because it's confusing even to me. So this is limit as x approaches 0 from the right. This 1 over x times, this is negative 1 over x squared. So I can multiply by the reciprocal now. X squared over negative 1. Now this x can cancel out with the squared. So we get limit as x approaches 0 from the right of negative x, and that equals 0. So now we have seen how to use L'Hopital's rule
to help us find limits in indeterminate forms.